Identify at least 3 ways that you can help prevent pollution from entering your local waterway through these resources. What can you guys do? To help with the smooth execution of this lab, there are 6 logistical steps that should be done prior to your scheduled lab days. First, you and your students will want to watch the wastewater management video and review at least Chapter 1 and 2 in the lab book. Discuss with your students why it is important to learn about water quality, how do the testing parameters indicate water quality, what are the differences between wastewater, stormwater, and drinking water, and how are they connected in the water cycle. Second, provide each student with an electronic or hard copy lab book and workbook. Select activities and/or homework assignments your students will do based on your learning objectives. Grab a pair of goggles. Third, safety, safety, safety. We want to make sure this lab experience promotes best practices in the science laboratory. Review Fairfax County Public Schools safety requirements with students and remind them of the importance of safety. This must remain the most important thing throughout the entire lab. Also, parents and students must sign the agreement by student and parent in the workbook and return to you by day 1 of the lab. This agreement addresses the potential hazards throughout the lab, which includes the use of microorganisms, how horseplay can make the student liable for the cost of broken equipment, and the proper disposal of all materials, including contaminated gloves. This agreement must be collected by Fairfax County Wastewater Management and maintained as a record for 3 years. What do the dried up coffee grounds represent? It does not represent poop. Fourth, let's set out our lab equipment. Each class will have their own set of 2 tanks, 1 sedimentation tank and 1 aeration tank. This lab starts with using the sedimentation tank. Make sure the valve is closed and fill with tap water until about 3/4 full. Here's another hint. I like to identify the class period on each tank with a Post-it note. I also make photocopies of the data table from the lab book and hang it just above their tank. This is where I record all the class data. You will also need 2 electronic balances, 2 1,000 ml beakers, 8 to 10 50 ml beakers. You can also check the lab book for a complete list of materials needed. There's no particles in it because what turbidity is measuring is the particles that are inside or floating inside of our water. Fifth, review the 4 testing parameters that students will conduct 4 different times throughout the lab. Your students should understand the importance of each test in helping sustain the environment. Directions for each test are found in the lab book as well as provided with the testing equipment. pH that is too high or low is harmful to the microorganisms used in secondary treatment process and to the aquatic life once water is released back into the environment. In this lab, students will monitor the pH of wastewater process with test strips. Test for ammonia. Ammonia has a pH of 11. It introduces excess nitrogen into rivers and streams and is toxic to aquatic organisms. In fact, ammonia is the most toxic nitrogen compound to living organisms. Testing for ammonia should lead to discussions about the nitrogen cycle and eutrophication. In this lab, students will monitor the ammonia of wastewater using an ammonia strip. Test for turbidity. Turbidity measures the water's clarity. Highly turbid water makes it difficult for fish to breathe and plants to grow as sediments clog gills and block sunlight. In this lab, we will use a colorimeter to measure the turbidity. Test for chemical oxygen demand, COD. The COD test measures how much dissolved oxygen aerobic microorganisms have consumed while removing pollution from the waterways. There is an inverse relationship between COD results and dissolved oxygen levels in the waterways. As pollution increases, dissolved oxygen remaining in the water decreases, resulting in high COD values. High COD values mean fish and other aquatic life will be deprived of the dissolved oxygen they need to survive. Water that contains too little oxygen to support life becomes anoxic or a dead zone. Safety tip. It is important for the teacher to be present at this station during all testing times since sulfuric acid is present in the COD vials.
Okay, so you take that and I will open up the top.
Students prepare COD vials using a micropipetter. Place vials in a digestion block heated to 150 degrees Celsius for 2 hours, and then they read the COD results with a colorimeter. Therefore, the results of the COD will not be read on the same day. So at the end of this, all 4 groups will have done all 4 tests. Sixth and last, put the students into groups.
You guys are all Group B.
Grouping your students is essential for smooth execution of the lab. For example, students can be placed into 4 groups representing the 4 testing parameters, or 8 groups representing the 8 ingredients. Groups will be used for preparing substances to create wastewater and for testing water quality throughout the lab. Another hint, I group my students according to the number of testing parameters. So I make 4 groups, A, B, C, and D. Those groups can be subdivided, so I end up with 2 subgroups, each performing the same test. This gives us multiple data points to help validate our results and increases the class engagement. By the end of the lab, each group will have conducted all 4 water quality tests.